We're going to be talking about matrix multiplication, not scalar multiplication, just strictly matrix by matrix multiplication for this video. So let's just jump right into it. A few things to note and a few things to remember, and we'll go over these and I'll show why these are not equal. But for one, matrix multiplication is not commutative. So matrix A multiplied by matrix B is not the same as matrix B multiplied by matrix A. Sometimes one of them may not even exist. May not exist, right? You might have AB exist, but BA simply cannot exist. And I will explain what that means and how that manifests later on, okay? And yeah, so let's just go ahead and get started with a few examples and I'll explain a little bit more as we go on. So if we have we'll start with the easy example where we have a square matrix, and square means that we have the same number of rows as columns. So either 2 by 2 or 3 by 3 or a 4 by 4. So in this case, we're going to do a 2 by 2. So we have 1, 2, 3, 4, just a simple matrix. And matrix B, we have 5, 6, 7, and 8. Okay? So very similar to the way, actually not very similar, but there are some similarities to the way that we do matrix multiplication and matrix addition. So I'm going to go ahead and highlight a few things. So the way we're going to go about it is that we're going to multiply the rows by the columns. So every single row entry, we're going to multiply by a column, and then we're going to multiply this by this, and then this by this, and add them, and all that. So I'll go ahead and show you as we get started. So since this is a 2 by 2, for one, this is something important to note, and this is a 2 by 2. If you put them together, we have 2 by 2 and a 2 by 2, okay? And we're multiplying them. So the way this is possible is because the number of columns in the first one is equal to the number of rows in the second matrix. If these are equal, then this is a possible multiplication. That means the solution to AB is possible, okay? That means we can find AB in this case. And in some other cases where they are not equal, where let's say this is a 3 and this is a 2, these are not equal, we cannot multiply, okay? And then these determine whether the multiplication is possible, and the outer ones, the row of the first one times the column of the second matrix, determine what the final matrix dimensions are going to be. So the final matrix is going to be a 2 by 2 as well, okay? So AB is going to be a 2 by 2, okay? So I'm just going to move this out of the way, and I'm going to bring this a little bit down as well, just right here, and we're going to work with it. All right, so let's continue. So the way we're going to go about this is we're going to multiply the first element here by the first column, the first element in the first row by the first element in the second row, okay? So this is how we're going to do it. We're going to do 1 times 5 plus 2 times 7, okay? So we're multiplying the first row by the first column. So we're multiplying 1 by 5 and 2 by 7 and adding them, okay? And then we're going to, once again, do the first column with the first row, sorry, with the second column. So we're going to do 1 by 6 plus 2 by 8, okay? So we do 1 by 6 and then 2 by 8 and we add them, okay? And then we do 3 by 5 plus 4 by 7. And the reason we get that is because we have 3 and 5, and then 4 by 7. So the way you want to kind of look at this, I'm going to highlight it a little bit. It's a little bit of this structure, right? You're going row based on the first one and column oriented on the second one, okay? And you're multiplying as you go. So here we're going to have second row, second column, right? Because this is the second row, second column position, so that's what we're multiplying. So we go ahead, 3 goes with 6, and then plus 8 by 4, or 4 by 8, just for the order's sake, okay? And then we go ahead and simplify this. We end up getting 5 plus 14, and 6 plus 16, and 18 plus 32, actually, and then 15 plus 28, and this finally goes into 19, 22, 43, and 50, okay? And that is equal to AB. And then if we go ahead and calculate BA to show um, what that will be, I'll go ahead and do a little bit quick. We're gonna get B is equal to 5, 7, 6, 8. We're gonna work with the same matrices, and then A is 1, 3, 2, 4. Once again, this is gonna be row oriented. It's gonna be column oriented, okay? And this is once again a 2 by 2. This is as well a 2 by 2. We see that these match. So this is a possible combination, and we're going to take the outer numbers, and this is going to dictate what our final solution is going to be. So B8 in this case exists as well, okay? And it's going to be a 2 by 2, okay? So once again, we're going to have 5 by 1 plus 6 by 3, and then 5 by 2 plus 4 by 6. I'm going a little bit quicker on this one. And then 7 by 1 plus 8 by 3, and 7 by 2 plus 8 by 4. Okay, I'm going to go ahead and just walk you through what I just did. So here you can see 5, 5, and then multiplied by 1, 1. So first column, sorry, here. And then 6, 6, 3, 3. So you see where we're going, okay? And then for the second one, this is going to be the first row, second column right here. This position, first row, second column. So we use first row right here, second column, okay? So you're starting to see how it matches. So then 5 goes with 2, 6 goes with 4 right here. And then if we take this one, for example, this is in the second row, first column. So we're going to look at second row, first column, okay? And so on and so forth. And then if you want to try this as an exercise, you can go ahead and calculate this matrix. I'm not going to go ahead and do it. It's just simple addition and multiplication. You add up and everything, and you get a 2 by 2 matrix, and that sums up what our B times A matrix is going to be, okay? Now let's do a more interesting result where we try to multiply a matrix that is not square, okay? So let's take this matrix where it's 2, 4, 3, 5, 1, 6. So this is a 2 by 3, okay? And this is structured as row by column, okay? So we have 2 rows, right? Let me highlight them for you. So this is the first row, and this is the second row. And then we have 3 columns, 1, 2, 3, okay? So it's a 2 by 3, and then B is 7, 8, 9, 10, 11, 12, okay? And this is a 3 by 2. As you can see, we have, this is a row, another row, and another row. And then we have 2 columns, 1 and 2. So it is a 3 by 2. So something to note is that AB is going to be 2 by 3 multiplied by a 3 by 2. And as we mentioned previously, you look at the inside numbers, where it's the column of the first one with the row of the second one. If these are equal, then this solution exists, and then you take these, and that will give you the dimension of the new matrix. So AB is going to be a 2 by 2 matrix, even though A is a 2 by 3, and this is a 3 by 2, we end up getting a 2 by 2. So none of them are the same, right? So this is something that comes up. And then if we do B times A, we're going to get 3 by 2, right, from here. This is a 3 by 2, and that's B first. And then we get A, which is a 2 by 3. Once again, we see that these match up. So this solution exists, okay? And then we get the numbers over here, 3 by 3. We see that BA is a 3 by 3 matrix. So now, something to just look back and remember, A is a 2 by 3, B is a 3 by 2, AB is a 2 by 2, and BA is a 3 by 3. So none of these are the same, right? And this is an interesting find. And that shows us that AB is not equal to BA simply because they don't even have the same size. They're not even the same dimension, right? And the way you go about multiplication is just like we did previously. It's not difficult at all. You go in, you work through, and you see what you can make. So you just go multiply row oriented for the first one if you're doing AB, column here, and then if you're doing BA, you do the opposite, okay? I'm going to do the multiplication all the way through again for just another example, but I want to show something where, let's say I have a square matrix, right? 1, 2, 3, 4. Okay, so this is a 2 by 2. And then we have B, which is 1, 2, 3. Okay? Wait, no, sorry. We need this, let's say it's just 1, 2. Okay? So this is a 2 by 1. This is a 2 by 1 because you have two rows. This is one row, two rows, and you have one column. Okay? Here you have two rows, and then you have two columns. So it's a 2 by 2, here you have a 2 by 1. So something to notice is that AB is going to be 2 by 2 multiplied by 2 by 1. So as you can see, once again, these inside numbers match. So now we know that this solution exists and that our solution is going to be a 2 by 1. So AB is a 2 by 1. Okay, but let's say if we take BA. Okay, as I mentioned, this is not commutative, so we have to check if the solution even exists. Okay, here you see a situation where the numbers do not match in the middle, where the number of columns of the first one does not match the number of rows of the second one. So this solution does not exist. D&E stands for does not exist. It simply does not exist. We cannot find this solution. Okay, so this is one of the examples where it's a fringe case, it's an edge case where you cannot find the solution, and this is very important to be mindful of. Okay, so I'm going to go ahead and do the multiplication for AB, just to show you another example of doing the multiplication. You can look over it and follow through, and hopefully it helps you work things out. So I'm just going to erase this as well. So we mentioned that the solution is going to be a 2 by 1 equal to 2 by 1. Okay, and we're going to take it row oriented here and column oriented. Okay, so we're going to have 1 by 1 plus 2 by 2, and then we're going to have a 3 by 1 plus a 4 by 2. And I recommend as you watch this video to try to solve these before I show the solution, to pause and actually try to do them yourselves. If you try to watch the video through the first time and then go back and try to solve them yourselves without looking at the solution after you've tried to understand the concept, because that in that way it'll stick with you and you don't have to come back the next time you have to use this topic and reteach it. It will simply stick because it makes sense, right? You're not memorizing, you're understanding. So if we go ahead and solve this, just do the addition. You get 1 plus 4 and 3 plus 8, which is 5, 11. And this is a 2 by 1 as we predicted. Okay? So one final thing to note is that multiplying by the identity matrix, an identity matrix is just one where you have ones on the diagonals and it is square. So let's say we have A, B, 3, 5, 4, 5, 6. Then the identity matrix for a 2 by 2 space would be 1, 0, 0, 1. For 3 would be 1, 0, 0, 0, 1, 0, 0, 0, 1. And then for 4, it would be like 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0. So you see the pattern, okay? This is the identity matrix. And you can simply think of this as the number 1. In multiplication, if we do like 5 times 1, it's equal to 5, which is the same as 1 times 5, okay? So in this case, same thing with matrices. You can think of this as the number 1 in integer multiplication or just regular number multiplication. So AI is going to be the same as A. It's just going to give you A, okay? And I'm going to go ahead and show you that this is true. So AI, we have a 2 by 2 multiplied by 2 by 2. Once again, you see that these two numbers match, so this exists. And then you see that those two numbers give you a 2 by 2 matrix. And then you're going to get 3 times 1 plus 4 times 0. Once again, I'm just going to show the orientation of going this way. You have row and column multiplication. Okay. Then you have 3 by 0 plus 4 by 1. And then you have 5 by 1. Sorry, plus 6 by 0. And then you have 5 by 0 plus 6 by 1. And then, sorry, I kind of crammed this into the corner. Just bring this right here. And then you're left with 3, 4, 5, 6, which if we just look at the original, it is the same matrix. Okay? So, and then if we try to do I8, right? Again, it's just 2 by 2 multiplied by 2 by 2. You're going to get a 2 by 2. We've done this multiple times now. Should be getting familiar. And then if we try it, 1, 0, 0, 1 with a 3, 4, 5, 6, you're going to get the following. I'll just do it on the next line. So this is going to be row oriented like this, row and column, column. Okay. So we have 3 times 1 plus 5 times 0, and then you have 1 times 4 plus 0 times 6, and then you have 0 times 3 plus 1 times 5, and then you have 0 times 4 plus 1 times 6, which will simply return 3, 4, 5, 6. Okay? Once again, just final example, you're multiplying 1 by 3, and then 0, right, by 5, because that's like first row, first column, first row, first column. Okay? And then let's say for this one, this is the second column, first row. So second column, first row. You see what I'm talking about? And then here you have second row, first column, second row, first column. So this is row, and this matrix, you're thinking of column. Okay? So that concludes our matrix multiplication.